So in this question, I'm going to share with you how I went about doing this problem and what I would be actually doing under exam conditions, because I don't want to give you a perfect explanation after the fact, which is not the reality of the GMAT. So in this question, they've given us these 5 denominations of coins, and we're told that a jar contains exactly 100 cents. And they're asking for possible total number of coins in the jar. Now, in this problem, I am going to use the answer choices because the number of possibilities is many, and so it doesn't make sense to approach it by finding all the possible cases. It's better to look at the answer choices. And we start with the first one, 91. We know that we need to have a lot of the pennies or 1 cent. And most of the students might be able to see that if we have 91 cent coins, then the remaining value, which needs to be 10 cents, can be obtained by having just one 10 cent. And this means that 91 is possible. So one works. Second one is a little bit tricky, and I think I tried to come up with an example quickly, but I wasn't. So then I moved on to the next one, and that's again a strategy you might have to do in the exam. So 76 here, again, most students are going to think 71 cent coins, and then I'm left with 6 more coins. And then you say, well, if they are all nickels, 5 cents, well, that's 30 cents. That's 70 cents, 100 cents total. So I know 76 works. So most students are going to get to this point. And if you look at the choices, it's really between D and E. So at least you've narrowed it down to 2. Now it's really about, is 81 possible? And again, I think I did spend some time with trial and error thinking if I can quickly show it, but that wasn't happening. That meant that I have to think in a more general way. And if we look at the sum of the values, you'll see that these are all multiples of 5. And this number is also a multiple of 5, which means that the number of pennies has to be also a multiple of 5. That means if the total is 81, our possibilities are 81 cent coins, and then 75, 70, and so on and so forth. And so we're going to just examine that case. So if you have 81 cent coins, then I have 20 cent left, but since there is no 20 cent coins, this is not going to give me a solution. And then next is with 75. So that's 75 cents. I have 6 coins left, and now the lowest value of a coin is 5 cents. So if these were all 5 cents, that would be 30 cents. But now the value is 105 cents, which exceeds. So that's not going to work. We do 70. Then I have 70 cents, and then I'm left with 11 coins. And again, that's not going to happen because 5 cents, that value is 55 cents. And you'll see that all of these cases would give me values that are higher than 100 cents. So I know that it's not going to be possible. So the key thing here was to recognize that all of these remaining coins had values that were multiples of 5. Therefore, the number, and the way you can think of this if you want to look at algebra, is if this is x, and then let me just call it y. Just let me drop the cent thing. Z, W, X, Y, Z, W, let's say T. Then you'll see that I can factor a 5 here. So this is a multiple of 5. That means, and I have a multiple of 100 here. Since all of these are integer quantities, x also has to be a multiple of 5. So that was the key insight. And as I mentioned earlier, if you're not able to quickly come up with an example, which is the case here because there are actually no examples, you may have to think in a more general way to prove that, yes, indeed, that isn't possible. And that's how you would be able to narrow it down between D and E. So in summary, the answer is 91 and 76 are possible. The answer is D.